Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Good day, grade 9 learners. Welcome to today's Natural Sciences lesson. My name is Naoma Shile. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Welcome to the Natural Sciences lesson, where we are going to discuss parallel circuit. It's from the series and parallel circuit under the knowledge area of energy and change. So do not forget to get in touch with us on our WhatsApp line, which is 079 5782 908. Again, 079 5782 908. Okay, let's go in. Today's lesson, I want you by the end of this lesson to explain that the voltage is the same across each resistor that is connected in a parallel circuit. Also, I want you to explain by the end of this lesson that the total current through the battery is equal to the sum of the currents through the resistors in parallel. Again, I want you by the end of this lesson to compare between a series and a parallel circuit. And then lastly, you should identify that the total current in a parallel circuit increases as more resistors are added in parallel. Please refer to the grade 9 CAPS document on page 73. Okay. Already you should know in grade 5 you learned about electric cells. There are the cells there and the battery. So remember, a cell is a single unit, but the battery is a collection of cells. Also, in grade 6, you learned about the means of electricity, like fossil fuels, how they generate electricity. There's an example. Also, in grade 7, you learned about the supply system, the national grid electricity in grade 7, and then in grade 8, you learned about energy transfer in electrical systems. Okay, I'm going to give you 5 minutes. I need you to go through this activity. I'll read the questions for you first. Question 1 says, do we connect an ammeter in a series or in a parallel circuit? And I need you to provide a reason for that. The second question is, what happens to the current in a series circuit when we add more resistors to it? The third question is, what is the unit of measurement for current? And the last question is, what happens to the voltage flowing through the battery when we add more resistors in parallel? 5 minutes. Welcome back, my grade 9s. Let's solve the baseline activity. Number 1. Do we connect an ammeter in a series or in a parallel circuit? We also have to do number 2. What happens to the current in a series circuit when we add more resistors? The third one is what is the unit of measurement for current? And the last one is what happens to the voltage flowing through the battery when you add more resistors in parallel? Anyone to answer the question? Oh, we have a hand. Paul, yes. What do you say? What's number 1? All right. Paul, here's your question. Whoa. Limit your hands. Okay. Number 1. Do we connect an ammeter in a series or in a parallel, and why? Yes. In a series, we do connect an ammeter. Why? Because an ammeter is a very low resistance and allows the flow of current. Number 2. What happens to the current in a series circuit when you add more resistors? Yes, it remains the same. Current remains the same when you connect, when you add more resistors in a series circuit. Number 3, what is the unit of measurement for current? Yes, it's an ampere, written in A. The last question, what happens to the voltage flowing through the battery when we add more resistors in parallel? The total voltage of the parallel connection is equal to the total voltage of the circuit. Give yourself 2 marks and pat yourselves on the shoulders for getting them correct. Let's move on. Okay, so in this lesson, already you should know these key terms. What is a series circuit? A series circuit is an electrical circuit that only has one pathway for current to flow through. You should also know this term, current. What is current? Current is the flow of electricity or charge through a conductor. Also, you should know what is an ohm with this sign. So this sign is a sign of an ohm. An ohm, what is it? An ohm is the unit of measurement for resistance, because in this lesson we are dealing with what? Parallel circuit. We will talk more about resistance and what it do to our circuit. Moving on. We are going to learn about also ammeters. What is an ammeter? An ammeter is an instrument for measuring electric current and it's measured in amperes. Another term is the parallel circuit, an electrical circuit that has more than one pathway for current to flow. We will also show you an example regarding a parallel circuit that has an electrical current that has more than one pathway for current to flow through it. Okay. In parallel connections, in our parallel circuit as well, there is more than one pathway for current to flow. Also, there is also a separate path through each component in parallel, and the potential difference is the same throughout all the components. This is our parallel circuit. Like we have stated, there is more than one pathway for current to flow. Let's look. This is pathway number 1 and then this is pathway number 2. This is our parallel circuit. Oh, there it is, our parallel circuit. Another point says there is a separate path through each component in parallel. As you can see, there's 2 paths there in our diagram. And then the last point says the potential difference is the same throughout all the components. What do they mean by the potential difference? They mean the voltage. It's the same throughout the whole circuit. All right, we move on. This is another example of series and parallel circuits. On the left here, on my left, here we have a series circuit with 2 light bulbs, and then here we have a parallel circuit. You can see there's a cell here and 2 bulbs. So in a series circuit, bulbs can also act as resistors. So the bulbs will not glow brighter in a series circuit, but then in a parallel circuit, bulbs will glow brighter. Why? Even if we remove one bulb, the other bulb will still be the same. Okay, let's move forward. Resistors connected in parallel in a circuit, or resistors can be connected in parallel in a circuit. Like I've mentioned on our previous diagram, that Also, bulbs can act as resistors, and look at them here. They are connected in parallel. As I've said, resistors can be connected in parallel in a circuit. Also, the voltage is the same across each resistor connected in a parallel, like we have mentioned. And there is our formula or our example saying voltage 1 is equals to V2, and it all equals to the total sum of the voltage. A parallel circuit, when you get more into it, we know that it provides two or more pathways for the current passing through it. Also, the components in a parallel circuit are connected in a parallel. Also, in a parallel circuit, the current is divided between the components of the circuit. Therefore, current increases as more resistors are added in parallel, and if one doesn't work, then the others will continue to work. Like I've shown you on our circuit diagram, where there's two bulbs. If you remove one bulb, the other will continue to work, and the current will increase even if you add more bulbs in it, because bulbs also act as resistors. The last point is, this is because a parallel circuit offers an alternative route for the current to flow through it. We will also show more examples about that. There we go. This is our example of a parallel circuit. You see, we remove one bulb, it goes off, but then the other two bulbs, they do what? They are still on. Because why? The current increases as more resistors are added in parallel, and if one doesn't work, which is this one, then the others will continue to work, like it shows here on our example. Why? Because it offers an alternative route. What do they mean, an alternative route? They mean that it gives another way for the current to flow. All right. I want you also, again, to do this activity 2. We'll mark it together. Each question equals 2 marks. And then I will give you 5 minutes, and then we'll solve it together afterwards. 5 minutes. Welcome back, grade 9 learners. This is our activity that we should solve together. It's written activity 2. It's written activity 2 because you are going to do 2 activities in this lesson and we are working from up to the bottom. So activity 2. It says, consider the following circuit diagram. On the right, this one, all the bulbs are identical. So this is bulb 1, this is bulb 2, and then this is bulb 3. What is identical? It means all the bulbs are what? Are the same. Okay. Number 1, it says, state with a reason what do you know about the current through light bulbs 2 and light bulb 3. What can you say? What is the reason about the current that's flowing through light bulb 2 and 3. The second question says, compare the current through the light bulb 1 with the current through light bulb 2. And the third question says, if the light bulb 2 blows, light bulb 3 will continue to light. Interesting. We also should give a reason for that. So let's answer it together. Number 1. Our reason about what we know with the current that flows through light bulb 2 and 3 is because the current through the light bulb 2 and 3 are equal to each other because they are connected in parallel. Do you get it what they mean? They mean the current that flows through the conductors or the wires through the light bulbs, which is 2 and 3, it's equal to each other because they are connected in parallel. Also, second question says, compare the current through light bulb 1 with the current through light bulb 2. Here's our light bulb 1 here and light bulb 2. You see our light bulb 1 is connected in a series, and then light bulb 2 it falls part of what? A parallel circuit with bulb 3. So now, let's compare bulb 1 and bulb 2. What's going to happen to them? Alright, the current through the light bulb 1 is higher than the current through bulb 2. Why? Because this is our cell and current flows through cell 1 first and it becomes greater than if it goes to the parallel bulbs. Because why? Resistance. Our bulbs act as resistors. Question, I'll give you 2 minutes to note down these solutions, then we'll answer more questions on the next slide. 2 minutes just to note down these questions, and then we'll go to the next slide. All right, grade 9s, I want your responses as well. Don't forget to get in touch with us on 079 578 2908. I repeat, get in touch with us on our WhatsApp line on 079 578 2908. All right, let's continue. The third question says, if light bulb 2 blows, what do they mean by that? Blows, goes off. If light bulb 2 gets off, light bulb 3 will continue to light. Why is that? Light bulb 3 will glow because there is another path for current to flow and pass by light 3. Remember, we said in our parallel circuit, the circuit diagram or our circuit provides more than one way of current to flow. So if light bulb 2 goes off, it means our current will still pass through light bulb 3. It's not restricted because there's more than one pathway. Let's take, for instance, I'll give you a common example. Let's say you want to go and get a Big Mac at McDonald's through a drive-through. You drive to drive-through, and when you get there, there's lots of cars, and you want your Big Mac. What are you going to do? You have another option. You will park your car at the parking lot and go through inside the store. That's another pathway for you to do what? To get your Big Mac. You don't need to stand in the line. So it's the same with our parallel circuit. The light bulb will glow because why? There is another path for our current to flow and pass through light bulb 3. All right, let's move on. Connecting resistors in parallel is it makes the total current through the battery to be equal to the sum of the currents across each resistor in parallel, provided though that the resistors have equal resistance. I think I should repeat that. The total current that flows through the battery to the circuit is equal to the sum of the currents across each resistors in parallel circuit, provided, keyword, provided that the resistors have equal resistance. However, if our resistors have different units or have different sums, or if our resistors are not equal, then the current will also differ when it flows through the circuit or across each resistor. But then the total that it flows through the battery is equal to the sum of the currents across each resistor in a parallel circuit, provided that the resistors are equal. There's an example. You can see our current in a yellow arrow flows through from the positive terminal to the negative terminal, and then it goes past by resistor 1, resistor 2, and then what does it do? It splits, and then it joins again. So the resistance in the circuit is what? The resistance is what? The total current through the battery is equal to the sum of the current across each resistor in parallel. So the current is the same. All right. Also, the total current in the circuit increases with each resistor that is added in parallel. Remember, we said a parallel circuit has what? More than one pathway. So if we add more resistors, it means there's what? There's low resistance and current increases. So the current in the circuit will increase with each resistor that is added in the parallel circuit. Let's look at our example. We've added the resistor in parallel, so our resistance will decrease. Here's another one. Example. We have our cell, we have 3 bulbs. Our bulbs here, remember I said they act as what? They act as resistors. And then the arrows and the line that are circulating, that's current flowing. If let's label our bulbs. We'll say light bulb 1, light bulb 2, and light bulb 3. With the green current that's flowing here, it means our current has taken a shorter route to flow and it makes our bulb to be bright. And then if you go to the blue current, it takes a nearer route to flow. Even if we blow out or we turn off bulb 3, our current will still flow toward on bulb 2, and so on and so on. Even if you look at this outer current that's flowing, the pink one, it goes to current 3. It takes a longer route. Our current in a parallel circuit always finds another way to flow. Another example, let's look at this picture. It shows a house with lights. What does it mean? It means even in our houses, in our ceilings, inside our houses, each room is connected and it has a bulb. So all the bulbs in the houses are connected in parallel. You can switch off in the dining room, you can switch off the lounge, you can switch off the kitchen. It depends on how you want to do it. But then all the houses, the modern houses, are connected in parallel circuits as well. Okay, another activity, which is activity 1, I want you to note it down. However, we will go through our questions together and then we will respond to that. We'll solve them together. I will also give you time to solve them. Number 1, what do we know about the total current through the battery in a circuit that has resistors connected in parallel? Question 2, what do we know about the total voltage across the battery of a circuit with the resistors connected in parallel? I'll give you 3 minutes for you to write down the question and solve them. All right, grade nines, welcome back. I understand we need to give you more time to note down the questions and answers. Don't worry, we'll give you more space and time. Okay, activity one. What do we know about the total current through the battery in a circuit that has resistors connected in parallel? We know that the total current through the battery is what? Is equal to the sum of the current through the resistors. Remember our diagram, right? It's like this, and then it has our cells and our resistors in a form of bulbs connected. Sorry, my diagram does not look good. But then the total current that flows through here is equal to the sum of the currents through the resistors. If it splits and it connects again, the current still stays the same. It becomes the sum. Okay, number two. What do we know about the total voltage across the battery of a circuit with resistors connected in parallel? We know that the voltage from the cell does what? Stays the same across each resistor connected in parallel and across the battery. I'll give you again 5 minutes for you to copy down the solutions and the questions if some of you haven't. Only 5 minutes, and then we'll go to the next questions. Alright, grade 9 learners, welcome back. I hope you had enough time this time to copy down the questions and the answers as well. Some learners say they need more time. Do not worry, I'll give you more time. So we have another questions. I'll give you another 5 minutes for you to note down these questions, and then we're gonna do the solutions together as well. 5 minutes for you to note down these questions, and then we're going to solve these other questions together as well. Alright, pregnant learners, welcome back. Let's solve our questions. What happens to the current strength when more resistors are added in a series circuit? Remember, this is it's more of a baseline activity you did. It refers you back on what you have learned about series circuit. What happens to the current strength when more resistors are added in a series circuit? What happens to the current strength when more resistors are added in the series circuit? The current what decreases. When you do what? When you add more resistors in a series circuit, the current increases. However, if we say what happens to the current strength when more resistors are added in a parallel circuit, what happens? The current strength increases. So it's an opposite for the series circuit and the latter forward for the parallel circuit. Again, the second question, what do you think will happen to the brightness of a light bulb if another light bulb is added in a series circuit? The brightness will not change. But then, that's not if you add it in a series, but then it will be when it's added where? On a parallel circuit. What will happen to the brightness of a light bulb if another light bulb is added in a parallel circuit? The light bulb brightness will not change. However, it will change if we add a light bulb in a what? In a series circuit. If you add a light bulb in a series circuit where there's more resistance and it acts as a resistance, the brightness will be dim. But then if you add a light bulb into a parallel circuit and you add more light bulbs, the brightness will not change even if you remove one light bulb. Yes, that's it. I'll give you again 2 minutes or 3 minutes for you to note down everything, and then we'll continue again. Alright, grade 9s, welcome back. Again, do not forget to get in touch with us on 079 578 2908 for our last segment of the lesson. And we are going to conclude. So let's look at our summary. If you have questions, you have this minute or two to send us your responses or questions, and then we'll be gladly respond to them. Okay, we already know that the parallel circuits provide more than one pathway for current to flow. I've explained it 2 or 3 times. If you want to know more about it, it's fine. We will discuss it again here. Remember, this is our circuit. My handwriting is not clear, but then I hope you see. And then now we have our bulb here. Let's put another bulb here. This is our parallel circuit. So remember, in a parallel circuit, our current has more than one pathway to flow. It can flow to this bulb, it can flow also to this bulb. Again, the voltage is the same across each resistor connected in parallel. Which voltage? Our cell voltage. It stays the same across each resistor connected in parallel circuit. It flows and then goes through the resistors, and then it still stays the same, doesn't change. The last point, the current that flows through the battery is also equal to the sum of the currents through the resistors. Like I have mentioned, this is our diagram. Let's say this is resistor. Let me do this. Let's put like bulbs here and say these are our resistors. When the current flows through the battery, it flows, it flows, it flows. The current is equal to the sum of the current through the resistors. So if it's 6 volts, this resistor will get 6 volt. Also, this resistor as a bulb also gets 6 volt, and then it flows again. The current stays the same right through. All right, good. And then another one. The total current in the circuit increases with each resistor that is added in a parallel. We emphasize the point again. In a parallel circuit, if there are more resistors added to it, the current increases, but then resistance decreases. Remember the example I told you about the McDonald's one as well. Also, resistors connected in parallel are known as current dividers. Why? Because you're connecting them in parallel to the circuit. They are called current dividers. So grade 9s, you've been a good, you gave me a good ear. So in the next lesson, we will be dealing with the safety with electricity. I hope to see you then. From me to you, thank you.